This is 7-2 exploring data. After we manually do a scatter plot and find the line of best fit, calculators can do this, and it's called linear regression. And when a calculator calculates the linear regression, they also give you what's called a R value. And our R values give us some information, and it basically tells us how awesome or how what information and how strong something is. So I am going to our values are from -1 to 1, and the closer they are to the -1 or the 1, the stronger they are. So I want strong positive. Well, first of all, I'm going to knock that out because it's too large. And the one that is closest to +1 is that. And then which values R represents data with a strong negative correlation between two variables. So I'm going to knock that out because it's not even within the parameter. And then this one is the strongest. So that gives you some information of how to read the R values. So the closer they are, so pretend that there's a number line, the closer they are to 1 and -1, the stronger they are. Analysis of data from statistical studies shows a linear relationship. The coefficient is the correlation coefficient, that's the R, is this, which statement summarizes, okay, it's not strong, it's not strong, it's not negative, and so it would be a weak positive. And we're looking at 0.8, 0.9, anywhere 0.8 and above to 1 would be strong. Negative 0.8 and below to -1 would be strong. If I have a 0.5, halfway in the middle, it might not be considered strong at all. I'm looking for 0.8s and 0.9s to be strong. Okay, we have a table, and this table shows the hours of TV watched. We want the independent variable X. So this is hours, dependent variable, score, equation of line of best fit, and this one we are now going to do Desmos. So I'm going to pause it, open up Desmos. First I'm going to do this, is I'm going to, going to take off my drawing, and I'm going to delete my drawing, and I'm going to Control C and copy my data, and then I'm going to open up Desmos in just a second. I have opened up Desmos. I'm going to add table. I'm going to Control V. Everything that came from what I copied is now in my table, and it is by dots. If I want a different color, I forgot how we change the colors, but you can change those dots to a different color if you want. I'm going to toggle between two screens. The first thing it wants is the equation of the line of the best fit. So I'm going to go back to Desmos and show you how to do it. So to find the line of best fit, I'm going to add an expression. I'm going to do y1 little tilde mx1 plus b, because I want a linear regression, and I'm going to push enter. Let me see. Sorry, these are 3s and 3s, so I'm going to change this to 3 and 3, and what it did is it did a linear regression. And so here, right here, my R value is pretty important. It's a -0.3361, tens, hundreds, thousands, 10,000s. That's how far you want it to be done. thing is when I look at this R, I know that it's a negative correlation from the sign, and I know that that is far away from -1, so it would be a weak negative correlation. And you can tell because the scatter plot is a long way from the line. So this is your slope, m equals -1.35458, and then there's your y-intercept. You will take the equation of line of best fit. There should be an x right here. So this should say y equals -1.3546x plus 87.1569. The slope is -1.3546. You are going to bring it out to the 10,000ths. That indicates to me that it's a line of regression number. And the y-intercept you're also going to pull out to 10,000ths. What does the y-intercept mean? It means that at 0 hours of TV watch, the quiz score is 87. And you're going to put it in the context of the situation.